Good afternoon, everyone, and welcome to the Department of Geriatric Medicine Grand Rounds. Before I introduce our speaker, I have a few announcements to make. This CME activity is jointly provided by the Queen's Medical Center and the UH John A. Burns School of Medicine, Department of Geriatric Medicine. At this time, please enter the name and credentials of everyone viewing Grand Rounds for CME attendance purposes. As a reminder, evaluations are required for CME. You can find the evaluations by following the link in the chat at the end of this talk or at any time on our website or our email advertisement. Your comments are very important to the planning committee and are used to plan future programs. It's my great pleasure to introduce our speaker for today, Dr. Scott Hoffer. He's a professor of neurology at the Oregon Health and Science University and psychology at the University of Victoria, British Columbia, where he holds the Harold Moore and Wilhelmina Moore Research Chair in Adult Development and Aging, and was director of the Institute on Aging and Lifelong Health from 2014 to 2022. His research has focused on the replicability and generalizability of results from longitudinal studies in the psychological and health sciences, with particular emphasis on integrative data analysis and innovations in study design and measurement. Over the last 15 years, he has directed the NIH-funded Integrated Analysis of Longitudinal Studies of Aging and Dementia, or IALSA network, comprised of over 130 longitudinal studies. The IALSA network with Maelstrom Research has developed an item-level metadata library to facilitate identification of relevant studies and measurement harmonization. He's also leveraging digital technologies to improve assessment of neurocognitive and patient-reported outcomes in home and clinic settings to enable earlier and accurate detection of change and improve the diagnosis and treatment of people with dementia. He's the past president of Division 5 of the American Psychological Association, past president of the Society of Multivariate Experimental Psychology, and a fellow of the Academy of Behavioral Medicine Research, American Psychological Association, Canadian Academy of Health Sciences, Gerontological Society of America, and the Royal Statistical Society. In 2016, he received an honorary doctorate from the University of Gothenburg. Please join me in welcoming Dr. Hoffer.
Kamal, thank you so much. Thank you for the invitation, and really a pleasure to be here in Hawaii and to have met you and a number of your other colleagues. What I'd like to do today is give you a very quick overview of what we've been doing over the last 15 years in the area of integrative analysis of longitudinal studies. I'd like to start with several slides that just provide a bit of context of why I started this right over 17, 18 years ago, and some of the ways that we've approached it. I'll describe the network and primarily the coordinated analysis approach and why we moved to this kind of analytic approach. There were really some necessary challenges as we sought to bring together multiple longitudinal studies to achieve some level of research synthesis or meta-analysis, finding the best answers to a variety of questions. And then I'd like to very quickly go through a number of recent published results, and just to give you a flavor of some of the questions we've asked and how we've approached it and what some of the results look like coming from multiple longitudinal studies from a very broad international context. Now, I've asked that this talk be made available to you. I provided a PDF, so I am going to be zipping through some of these slides fairly quickly, but I hope in a way that will kind of give you an idea of what the approach is, perhaps even how to do this approach. I'd be very happy to discuss it further with you, and really what some of the relevant findings and the importance of this is in the context of cumulative gerontological science. So I received a PhD in psychology and statistics in 1994. My advisor was in the area of cognitive functioning and cognitive development across the lifespan. These are the kinds of questions that I've been interested in asking and answering over the course of my career. When does aging-related cognitive decline begin? This was a really critical question, and it still is a question, because different study designs, primarily the cross-sectional age differences approach versus the longitudinal, give quite different answers. And we still don't have a good answer to this particular question. And we know that different types of cognitive abilities, memory and speed and fluid intelligence, verbal abilities, they tend to change at different rates across the lifespan. So we're really trying to get a better handle on that. And again, we don't really have great answers there either. I've been very interested in a life course epidemiology approach and how early life characteristics, different early life contexts, country contexts matter for later life outcomes. So you'll hear about some of our research contrasting country, but also birth cohort. And more recently, and something I won't be talking about today, is the question, is this individual changing more rapidly than they have in the past? This is the question of presenting with memory complaints, some cognitive decline, and really being in the difficult place to assess that and to capture those individual changes early. We know that from some of these long-term longitudinal studies that these kinds of changes occur as much as 10 to 15 years prior to diagnosis of dementia. But we really don't have the methods to capture those sensitive changes much earlier than even a couple of years. Also, we know when we measure people repeatedly, we see a retest gain, and this has always been an issue with longitudinal studies. How do we disentangle retest or learning from the kind of lifelong or slower kinds of changes we see? And more recently, we've done a lot of intensive measurement designs looking at stress and physical activity and sleep and how these daily dynamics really impact not only your ratings of your health, your well-being, but also your cognitive functioning at a daily level. And what we know is that many of these same factors that affect the daily level are these long-term risk factors for cognitive decline and dementia. So many of these same things play out at different time scales. So these are the kinds of things that I've been engaged in over the last several years. I just wanted to say this about cross-sectional designs. When I began my studies in the 90s, most of what we knew about aging came from the comparison of people of different ages. And often it would be groups of young people, middle-aged people, older people, or a wide range of ages within a cross-sectional study. And of course, these differences could be due to age, but they could also be due to the year you're born, to your birth cohort. So sociologists would approach the same kind of study design, looking at birth cohort. Psychologists and others would be maybe looking at in terms of age or aging. So that's a real confound. Also, of course, the selection population mortality, it's inaccessible in cross-sectional designs. You're just going in there, you're taking a snapshot of a person of different ages, and of course, you have a loss to follow-up. You're not able to sample people who have passed away. So these are some of the challenges. One of the contributions I made early in my career was that just the fact that we have these age-related mean trends, that the fact that cognition, health, physical functioning, hair color changes can often lead to these spurious results. I just had a change in my screen. I'm just trying to get a control of it. So I mentioned looking at birth cohort differences or these long-term historical differences. This is often what we're interested in terms of life course epidemiology, how early life context, early life exposures matter for childhood, adolescence, young adulthood, and later adulthood kinds of outcomes. So we're really interested in tracking these. Relatively few studies permit this, but we've been able to work with some of the long-term birth cohort studies in England, some in the US and elsewhere, to look at how these kinds of changes play out over time. Often it involves a multiple cohort comparison, so bringing multiple studies together with some data linkage to look at how these historical trends, generational trends, matter for some of these later life outcomes. And I'll mention some results later on. I just brought this in to demonstrate one such type of how an early life factor can be related to a later life outcome. This comes from the halcyon network. It's no longer around, but it brought together many of the British birth cohorts. Here they did a systematic review and meta-analysis of childhood socioeconomic status or position and physical capability later in life. And this just shows that across many of these birth cohort studies in England, that there is generally a negative association. Lower socioeconomic status is related to walking speed, to declines or lower levels of walking speed. But you can see that most of the studies have non-significant values. Overall, there is an effect, but there's a lot of heterogeneity here. And so one important thing to do is to bring together these multiple studies to capture the signal better, and also begin to understand that heterogeneity, the differences across these studies. It is the case, and often what you'll see what we've done later is we've often begun with a systematic review, and then we followed up with a new analysis of longitudinal studies that haven't been published yet. So we're really trying to augment it. But I just wanted to show you early on what this is about. We were interested in the question, how do changes in physical capability relate to changes in cognitive capability? Again, from the cross-sectional literature in the 90s and early 2000s, there were these papers that were coming out with these very strong effects, this common cause idea that once you see a change in physical or cognitive, it tends to all go together. And what we wanted to do was look at this question from longitudinal perspective. There wasn't much evidence for it in the published literature. There were relatively few longitudinal studies, number one, but of those studies, the effects were really quite small. Nothing of the magnitude that we were seeing published based on these cross-sectional between person differences. So this is again kind of a motivation that led us to bringing these multiple studies together. And these kinds of issues, this kind of thinking was what led me to develop this international network, the Integrative Analysis of Longitudinal Studies on Aging and Dementia. We've been funded by National Institutes of Aging for about 15 years now. We have 2 current grants. You'll see some of that activity later on. The number of studies has grown over the years, and we'll often work with up to maybe 15 studies on each particular question. You can imagine that these studies differ quite a bit from one another. They cover different age periods, different birth cohorts. They often have different kinds of designs. Some measure only once every 7 years, but with follow-up for up to 30 or 40 years, like the Seattle Longitudinal Study. And others maybe even ranges of 6-month periods or 1-year periods. Those are relatively rare. Most longitudinal studies are between 2- and 3-year follow-up periods. And what we were really focused on was replication of results, the direction and pattern of results across these different populations, different countries, cultural contexts, historical periods, different measurements, designs, and statistical models. And you'll hear some of this as well. So when we began, it was really hard to find out what data were available in many of these long-term or these longitudinal studies. We knew what was being published, and we were able to begin to map out the studies themselves and the study teams and making this contact, but there really wasn't a catalog that we had to be able to identify which studies had the particular variables necessary to answer the questions we had or anyone had. And so we began working with Maelstrom Research. Maelstrom grew out of this public population project in genomics. It was a metadata catalog for these large genomic studies. They hadn't worked with any longitudinal data at the time. So we began their longitudinal metadata catalog, working with Isabelle Fortier there. And it is now the largest catalog of this platform. And a number of these other consortia, many in Europe, began with the data that we've built and has continued to develop it out in this way. So it supports a number of current and past network consortium. It is a searchable metadata catalog. It uses very close to the DDI metadata structure. So what you can do here on this platform is search for the variety of variables you would like to see, you require for answering a particular question, and you'll find which of the studies have these kind of data. So I really would encourage you to have a look at that metadata catalog, and it's been a lot of effort over the last 10, 12 years to pull together, and Isabel and their team are just superb, and they would be happy to work with you to identify your searches, this kind of thing, to identify the studies that are relevant for answering particular questions. Now, I mentioned we often start with a summary review, and often we find that study results differ from one another quite a bit. And there's a number of reasons why we might find differences across different published studies, seemingly asking and answering particular questions. One major issue, of course, are the measurements that are being used. They may not be equivalent, they may not be identical, and they may even be somewhat distant from one another. The populations and samples, of course, country and birth cohort is of interest. The design factors, often we can deal with the kind of number and spacing, duration of observation within these studies statistically, but it still might matter. It may be that some studies that measure more frequently have more or less retest effects, and that may be related to some of the analysis of change we're focusing on. And of course, the selectivity or incomplete data has to do with initial sample selection, but also how well a study did in terms of follow-up. Retest effects are really an interesting issue. I know early in my career, for years, we weren't seeing much come out of these longitudinal studies on cognitive aging, these kind of changes in cognition, because often in the first two assessments, we would see gains in functioning, really quite different, unexpected relative to the cross-sectional studies that were really dominating the literature at the time. It was when we began to understand these as retest effects and some ways to statistically model these out that we began to see more and more going on here. So, okay. So I want to finish by 1:15. So I've got about 25 minutes. So I'm just going to step through this maybe a little more quickly, but not this part, because this is how we've approached it. Many longitudinal consortia may have a defined purpose. They want to come together to solve some particular questions. So a variety of studies come in, and the first part is harmonization, to really be able to equate different measurements across studies such that they could be compared. But often these consortia are formed where they really want to pool the data. They want to pool the data into a single data set and run a single analysis. And this requires a very rigorous type of harmonization, exact harmonization, where we can move any one measurement onto a common scale and analyze it as a single data set. Early on, we saw that this wasn't really possible. And so we began what I called a coordinated analysis. And here we wanted to really maximize the data value from each study while making the results as comparable as possible. So in the published literature, there are many things that can differ. And I just showed you some of those, but the measurements, the statistical model, the analysis, as well as study differences in other ways. So we really wanted to control what we could control. And we would expect that we would reach similar conclusions, that pattern and direction of results at the construct level. So again, in cognitive functioning at a primary memory or a speed of processing or a personality factor, regardless of the exact measurement. But if we knew these to measure a narrow factor, we would expect similar findings. The most important thing we do with a coordinated analysis is use the identical statistical model. So we select studies that have construct level variables that do have all or most of the covariates that we want to adjust for or evaluate as an effect modifier. And then we're able to run these models and combine these results so that we can actually compare, contrast, and run a meta-analysis in most cases. We have over the last, or since we've been running this, I'm very interested in the statistical model and how differences in statistical models can lead to differences in results. So we've often run sensitivity analyses there, and we'll often end each paper with a meta-analysis or meta-regression to understand the heterogeneity of these effects. So this idea of coordinated analysis, it kind of fits within the broader replication. Often what has been done is one study will produce a finding, and then another study that has similar data will attempt to replicate that finding. So this is kind of this idea of sequential replication, often leading to publications that are years apart, and it's very hard to accumulate this. And this is what we find when we really try to do a summary review and meta-analysis from existing literature. It's very hard to directly contrast and compare, and we're often squishing things together that we really can't or shouldn't. When we can do that, when we can look at standardized effects from published studies, we can run a meta-analysis and kind of get the best answer based on the best available published data. What a coordinated analysis allows us to do is very quickly get new results from existing longitudinal studies in ways that maximize the comparability. So we can select studies that have factor level outcomes, very similar types of outcomes, similar covariate sets, and run the identical statistical models on them so that we can achieve this level of meta-analysis that we can't achieve from wild type study results. Now, when possible, and many genomic studies require this, is when these data, variables, measures, phenotypes can be rigorously harmonized, they can be pooled into a single analysis and permit what's called a pooled data or individual patient data meta-analysis. And I just from my own experience in working with these studies and working with the kinds of questions we've been asking, data pooling just hasn't been possible. It's rare that we've been able to do that. And so what happens when measures do differ across studies? What to do when measurements differ? Ideally, we could co-calibrate or harmonize these. And there's a variety of methods, factor analytic methods, item response methods, where this can be done. And we have engaged in this whenever possible. What some of these consortia have done is select items across studies that are identical. So basically throwing out items that are different, but selecting those 2 or 3 items that are sufficiently similar, combining those into a small index and running analyses on that. You can select studies that have identical measures. It quickly moves down what you may have, 15, 20 studies that have opportunity to be contrasted. You might move down to 2 or 3 studies very quickly if you rely on that approach. We can compare standardized effects. This is what we've done in some cases. I'll show you some results from that. And you can compare general factors. This has been done in some of the genomic studies, but it requires a large number of items to get an exchangeable general factor. I've done some simulations on this. It requires upwards of 16 or 17 variables to get a sufficiently exchangeable factor across different studies. So what we've done is really rely on this construct level comparison, and that's the coordinated analysis approach. And I think this just makes the same point I made. These are several factors of types of processing speed. This is the symbol digit substitution test, the choice reaction time, a processing component. And this just shows how some of the studies have measures that fit under those narrow constructs where the actual measurements might actually be a little different across studies. But it allows us to bring them together at that construct level comparison. I like to think of this integrative data analysis or coordinated analysis as providing us opportunities to test new hypotheses. Cross-method, that's a bit of a methodological focus, of course, where we're interested in the sensitivity of design and statistical analysis to different types of results. But on the more substantive area, we're interested in cross-cohort differences, how differences in birth cohorts, such as birth cohort trends that seem to be underlying some of the incidence of dementia trends recently, and how do these risk and protective factors, how have these changed across different birth cohorts that might lead to these differences in dementia outcomes? Cross country, there's opportunities for natural experiments or generalizability questions. Long-term longitudinal, this is the life course epidemiology. And of course, prediction. Where we'd like to get is to where we can kind of take what we know across some historical time and from a variety of national, international studies to extrapolate about what comes next. Now, this is on the more practical side. With IALSA, we've moved to a workshop model. This is where we bring often early career investigators, early career faculty, or team members from a variety of studies together to perform the analyses together for across several days. Part of this, and a large part of this actually came to be because of challenges with data sharing. It's difficult or impossible for some colleagues to share data across international boundaries or for a variety of other reasons. And we found that this kind of workshop model doesn't require data sharing at all. The individual from the study will come, they'll be performing their own analyses. We'll often provide training in the advanced statistics. We'll have people there to assist and help. But what happens over time is that everybody begins to work with each other. The data isn't shared, but everybody's able to really work together to bring about these new results from each study, which then can be shared for meta-analysis and jointly authored papers. And this is really the major model we've used to achieve most of our results. I just have a few slides here about heterogeneity. I think I've already said quite a bit about it. It is the case that one or two replications of a particular finding is often insufficient, just given the range of variation across studies that are looking at the same result. We need more than that. It's important to understand the range of heterogeneity and maybe what explains it. And these are often challenging problems. I've tried to tackle the measurement heterogeneity issue a number of times in my career. It's a big problem. It's a big challenge. We really need a large effort to map measurements onto one another using all the available data as best we can. It's hard to do it in small multi-study contexts that's going to have any lasting benefit to the field. Okay, so the outcome here really is some degree of research synthesis to produce new results, a sufficient number of new results that we can begin to arrive at what the best answer is currently. We understand that there's going to be differences in results due to measurement heterogeneity. We've achieved that through some degree of harmonization, but also construct level comparison. We understand that there's going to be analytical heterogeneity. So this is across differences in study designs, primarily when you're looking at the literature, different analytical models that may yield different results that are non-comparable. There's a variety of models of change that are just not comparable. You can't really tell whether this is the same pattern or type of change that we see across different analytical models in many cases. The population heterogeneity is often part of the question we have. Does this generalize across birth cohorts, across countries and culture, across age groups, across gender, this kind of thing? So this is often part of the question. So when we approach any analysis project, we look at the sources that need to be equated or harmonized, certainly the research question, leading us to identifying the measurements that are required to answer that question, the statistical model that is going to be best fit that question, And that's when we begin to look at the metadata catalog. We identify studies that are valuable for this and have sufficient measurement. Also, when we think about the statistical model, we think about the sources, the covariates to include, as well as to be contrasted. So the interaction terms, the moderators, the effect modifiers. So this all goes into developing the analysis project. So several years ago, we started this particular project, and it took a few years to complete. It was a big one. So this is where I've kind of given you a bit of an overview of IALSA, the network, the reason for it coming together, and some of the ways that we've approached the analysis, and using analysis workshops as the primary vehicle to really pull new data together, to provide new training for often early career investigators, but also to achieve new answers for our questions. So what I want to do now for the next maybe 10 minutes is go through a series of results. And again, I'm going to go through these rather quickly, kind of give you the general result from each of these studies. And you can get to the PDF if you want these references and look into this further. And again, I'd be very happy to meet with you if you like. So this is, we worked with a graduate student at University of Victoria. In the cross-sectional literature, we were finding all of these papers with very strong results of pulmonary function, of grip strength, of auditory acuity, hearing, vision, related to cognitive decline. All of it was based on between-person differences, contrasting people of different ages. And again, the problems primarily of mean trends, all of these things change on average with age, and that will confound the results of cross-sectional research. So we wanted to bring new results from the longitudinal studies to answer this kind of question. Is there a general change across physical and cognitive types of functioning? So this is one of the papers. We began with a systematic review, and we used PRISMA guidelines. We reviewed all the literature. Only 4 studies that we could find investigated cognitive and pulmonary longitudinal associations. Our criteria was that each study had to have three or more measurement occasions. We really wanted to look at change in pulmonary function related to change in cognitive functioning. And there weren't very many results out there. Of those results, they differed widely, and often because different statistical models were used, we think. So this was published, and we couldn't make any firm conclusions of what was published already. So we then kicked off a new coordinated analysis of pulmonary function and cognition. So we brought together, how many studies did we bring together here? We brought together a number of studies that combined was over 20,000 participants, 8 longitudinal studies. We did a coordinated analysis. We fit bivariate growth models. So these were linear and linear quadratic models of change within each study. And then we computed the standardized effects of the correlations between baseline functioning, rate of change, but also the occasion-specific variability, whether a person was above or below their growth curve on any particular measurement occasion. This idea of kind of state fluctuation. What we found in this case was that there was really no association linking changes in pulmonary function with changes in processing speed and attention. I'm sorry. For many of the cognitive domains, there was no association. There were very weak associations between pulmonary functioning and processing speed and attention or working memory. So really limited evidence for a consistent link between these changes in pulmonary and cognitive functioning. There was, of course, some associations between baseline level and no associations with occasion-specific variability here. So really quite different results than we find in the cross-sectional. This just shows several of the studies that had measures of processing speed and two types of measures of pulmonary function, forced expiratory volume and pulmonary, I forget what that means. But what you can see here, the important point here is that these associations, even at baseline, are relatively weak, are weak, on average of 0.17 correlation, with some degree of heterogeneity between different studies. What we were looking at, though, was whether changes in lung function were related to changes in cognition, in this case, processing speed. And again, here on average, we find that there was a 0.16 correlation, very small, only a couple percentage of variance explained in these samples. And it was probably largely dominated by one particular study, the Longitudinal Aging Study Amsterdam for MIN, coding and PEF. But you can see that most of the studies are non-significant, but that combined, we do get a very small, weak effect. So this is the type of result we get when we look at questions across different longitudinal studies like this. We did the same thing for grip strength. Grip strength is often seen as quite an important biomarker of aging. And so we did exactly the same thing. We did a systematic review. Again, we found that 4 studies reported a longitudinal association between changes in grip and cognitive function. Let me see if I summarize this here. I didn't want to, well, let me keep moving ahead here. We found some association in the systematic review, but only 4 studies contributed. So we ran a new set of analyses on different longitudinal studies. And after adjustment, we found a moderate association between change in grip and change in cognitive domain in both males and females. And here the correlation was moderate, correlation of 0.55. So changes in grip are associated with changes in pulmonary function. But there was also a high degree of heterogeneity across studies. We didn't have enough studies that we were able to really explain that heterogeneity, but we did attempt it. So I'll just keep kind of stepping through this just to give you a flavor of some of the results. I'll go a little more quickly now so we can have time for some questions. This is one of the studies we did to look at how early life or adolescent educational attainment impacted later adulthood cognitive functioning. Really, the question was, is education a benefit or causal of later cognitive functioning, or is it just a selective selection because of childhood intelligence selecting into higher education? We really wanted to tackle this particular question. We used 3 of the long-term birth cohorts that had very similar measures. We were able to contrast that, and we did find very clear evidence of a beneficial effect of education on later life adult cognition around age 55, 56. And we did this by contrasting individuals who had the same range of childhood education, but went on to either a university degree or a high school degree. So those are the 2 different lines you see. And there's this offset between these lines, and that's the benefit of university degree over secondary qualifications, given the same range of childhood cognition. So really taking childhood cognition out of it, although it's related to later life cognitive functioning, education confers an additional causal bump in adult cognition. We moved to some multi-state modeling. This is where we looked at the effect of physical activity on transitions between cognitive states and death. We use multi-state modeling. In this particular paper, we used MMSE scores, and we provided some bands in terms of non-impaired, mildly impaired, severely impaired. We found that physical activity was associated with decreased risk of transitioning from non-impaired to mildly impaired and death. But we also found that that physical activity provided an additional protective effect after the onset of cognitive impairment, so some decline. So it basically, physical activity decreased the risk of transitioning from mild to severe cognitive impairment. but here the signal was less clear. There were more between study differences, but on average, that was the finding. My colleagues at Northwestern have, in our more recent grant, have been looking at how personality is related to mortality risk, but also perhaps an effect modifier for dementia. This is one of the bigger integrative data analysis we've done. This involved 15 studies. And what we found here was that neuroticism in particular was associated with a higher risk of mortality, conscientiousness, extroversion, agreeableness with a lower risk of mortality. So we were adjusting for smoking, a variety of other risk factors. And they were with this set of 15 longitudinal studies, we were able to identify some very, very weak effects. And I just want to emphasize weak effects. These associations are really quite small. You can see the relative risks for openness, 0.97, for conscientiousness, 0.89 for mortality. And I said neuroticism was larger, it's 1.05. So these are weak effects, but consistent when you bring together multiple studies. This is another paper that we looked at personality traits, cognitive states, and mortality. This is now within a multi-state modeling platform or analysis. And here what we found, higher conscientiousness, extroversion, lower neuroticism were predictive of maintaining quality, maintaining cognitive health. So lower risk of transition to MCI. And this was just within one study, the Rush Memory and Aging Project, which used actual diagnoses. I'm sorry, it's 1:12. I'm rushing a little bit, and let me just work to finish up. This is a more recent paper that looked at associations between personality trait, cognitive decline, and dementia. And I think this is an important one because this one basically shows no effect of personality on rate of cognitive decline or change related to dementia. There are some baseline associations. These are very, very weak, but no evidence that personality is related to rate of change. And again, this is the kind of approach, this coordinated analysis approach, bringing together some of the best longitudinal studies, answering a question. In this case, it's no, but we can say it more definitively because we found it across multiple studies. So the same kind of pattern and direction of change. Again, this is one of our more recent studies where we contrasted some of these large surveys, the HRS in the US, the Canadian Longitudinal Study, the ELSA, English Longitudinal Study on Aging, and TILDA in Ireland. Here we were interested in looking at specific patterns of disease across these different populations. What we found here was that the US had significantly higher prevalence of multimorbid disease relative to Canada, England, and Ireland. The socioeconomic gradients were more pronounced for the US, Canada, and England relative to Ireland. And we just looked at the obesity trends over the last 50 years, and that pattern looks strikingly similar to the changes we see in these results of multimorbidity within and across each of these countries. We've been interested in doing some more cohort analysis, trying to understand aging versus cohort changes and working through some of the latest models. This is just one paper where we looked at grip strength from an age period cohort model within the English Longitudinal Study on Aging. And here we conclude that it's primarily aging effects. There's really no evidence or minimal evidence for period or cohort effects in grip strength. So it's really an aging related biomarker, no evidence of really historic differences in the effect of that marker. And just to kind of wrap up here, some of my current activities, we're currently funded with an NIA grant to look at birth cohort differences in risk factors for dementia. We certainly do find some evidence of changes in cognition across birth cohorts. Actually, not changes, but just baseline effects. So here you can see different birth cohorts and how they're a bit staggered. So we're able to contrast birth cohorts as well as aging effects. And we see certainly that there are some differences across birth cohorts. What we've been looking at more recently, and we'll be able to provide these results quite soon, is how birth cohort is related to the variety of risk factors underlying cognitive aging and dementia. And this just comes from the Lancet article looking at a variety of these life course risk factors when they're thought to have their strongest effect. And we do see birth cohort differences in many of these in some of the studies we've looked at. We're working closely now with the 15 Swedish cohorts, bringing these studies together that really do cover quite a broad range of birth cohorts as well as age, where we'll be able to answer some of these questions in a much clearer way because we have a common language and many of these studies share very common variables. So we can achieve a high level of harmonization to really look at this question much more strongly. And in this case, we really do need to be able to pool these data in ways to be able to separate out birth cohort and age effects. So that's our current work right now. I just want to say it has been an absolute honor in working with so many of these longitudinal studies, the PI, the research teams. It has been really the best part of my career in life, and most of these colleagues have become great friends. And we've been able to work together, and once we work with a team or a set of individuals, it's so much easier to work together in the future. It hasn't always been easy. It certainly involves trust and building some level of trust that this is going to achieve something different than what might be done with any one study team or with any one longitudinal study. And I'm really happy to say that in most cases, this has worked out wonderfully. I mentioned, I think one of our biggest contributions too is we've held probably maybe 20 of these analysis workshops. And this is where we bring people together. We'll do a lot of work with them before they come to these meetings to get their data in order, to begin some of their statistical models. But then this is really the place where it happens. We often will have an expert in the statistical method and multi-state modeling, for example. We provide a training, and we provide all the statistical supports we can during that meeting, and we'll achieve results within a day or two. There were a few meetings where we actually were able to, in real time, permit people to upload results, and in real time, this meta-analysis would be formed. That hasn't carried forward. That was a lot of work, but it was a real joy to see that as people would put up their results, we would see the accumulation and overall pattern of results coming through. Anyway, this has been just one of the great parts of IALSA and working together with so many people all over the world. And just in closing, I just wanted to say there is IALSA. There's a number of other research consortia. There are many public resources, data repositories, metadata catalogs. It's possible to do multi-study research without too much trouble. I think it's often a great target for research funding to bring in a few different studies to achieve some replicability, some test of generalizability of effects. These are just some ways to begin to approach that. I'd be happy to meet and consult with you if this is of interest to you. And I've just found that this to be a great way to kind of optimize some of our science. The harmonization of variables is so important, and I think it's important for the development of new longitudinal studies. The result sensitivity of measurement analysis modeling decisions, this is important to know, and it's hard to know from the extant literature. You really get a handle on it when you're able to bring longitudinal studies together to ask new questions or ask old questions and get answers from many more data sources. Ideally, it provides open, direct, immediate comparison and contrast of results. Ideally, it allows new investigators to go in and begin where others left off, beginning with those analysis scripts, beginning with those same studies to extend and explore new questions. And that's what often happens in some of these new consortia. The problem is that funding for consortia are often limited, often 5 years. And we see that with many of the EU consortium. And, it takes 2 or 3 years just to get up and running where you can really begin analyses. And by then it's almost over. So that's been a real challenge to keep these kinds of activities going. And these are just a few of the other resources. And again, they're at the end of my slides. So Kamal, thank you so much. Thank you everybody for joining today. Happy to answer any questions.
Dr. Hoffer, thank you so much for an excellent presentation. Let's open it up to questions now for our audience. We have a small enough group that you can unmute yourself and ask the question, or if you'd prefer, you can put it in the chat as well. Do we have any questions for Dr. Hoffer? And while we're waiting for the questions, Michaela, if you could put the evaluation link in the chat as well. Please don't forget, if you want CMEs, you do have to complete the evaluation form. Dr. Hoffer, I was really impressed to see how you've managed to bring together so many different studies from various parts of the world. I cannot even imagine actually how difficult that must have been to get everybody to work together.
To some extent, the early days were most challenging, but we worked with, my background was, well, let me just start. I was over in England for a 2 years postdoc and began working with many of these longitudinal studies in England. And when I moved to Penn State as a postdoc in genetics, I worked with Jerry McLaren, who started many of the Swedish twin studies. And so I began working with that, and there were multiple studies and they were very similar to each other. So I worked with Jerry on a merit grant, and that was the beginning of my thinking about bringing together these studies in more powerful ways. And I then began working with Australians and others, and we began to see that there were similar problems, similar challenges with incomplete data and mortality and other things that these were the early days of trying to figure that out. So it began by being able to work together with many different longitudinal studies. And that's really how I also began, was the opportunity to get people to work together more, and really the value in bringing together studies to achieve these results that were more comparable. When I saw that was just kind of a natural thing. And I think people were on board, at least, for some of these early studies, building the network and expanding it in that way. That came over time.
That's great. Any other questions for Dr. Hoffer? Or comments from anyone?
How many people here work on some of your longitudinal studies, like the Hawaii Asia Aging study?
Several of our fellows and faculty over the years have been working on those data, and even some of our medical students have had the opportunity to do so. As you know, it's a very rich database, 50, I think we're now in the 58th year of follow-up. So
yes,
a very rich
it's remarkable,
database.
Really. Yeah.
Yes. Okay, well, if there aren't any questions, then I just wanted to thank Dr. Hoffer for a wonderful presentation, a very good overview on a very complicated topic. I know these are these types of analyses are very complex to do. And so thank you for summarizing them so nicely for us, Dr. Hoffer.
Kamal, thank you so much. I hope this is somewhat useful, and please don't hesitate to contact me if you're interested in any aspect of this research.
Absolutely.
Good. Thank you, Kamal.
Thank you so much, everybody. Don't forget to do your evaluations. Okay. Thanks, everyone. Okay, bye.